If you found Newton's second law in a textbook, you'd find, well, 3 or 4 pretty long sentences describing it. But I think the easiest way to summarize Newton's second law is just these 3 words. Force causes acceleration. Now, of course, we're going to have this very important formula that goes along with the law. Now, another way of saying this is this way. Unless a force is exerted on an object, it will not accelerate. Now, the examples I'm using here, I've chosen outer space. That's because there are no telltale forces out there like friction and wind and things like that. So we have an object here, a softball. He's sitting stationary. He's not moving, and there is no force. And we're going to see what happens to his motion later. Before I do that, though, we have another one here, another softball. Again, no force is exerted on it in outer space, but he is moving at 5 meters per second. Now, I said here, unless there is a force, it will not accelerate. So you should be able to predict what's going to happen to these guys. This guy's stationary, no force. He remains stationary later. We could say 100 years later, he would still be stationary. He's not going to move because there is no force causing acceleration. Down here, this thing can be moving at 5 meters per second. Later, even 100 years later, 1,000 years later, unless there's been a force, he's not going to accelerate, is he? He's going to stay here. No acceleration in this situation because no force, no acceleration. Now we'll try something a bit different here. We'll still stay in outer space, but now we're going to say in both these situations the force is exerted. Stationary softball is here, but there is a force exerted to it now in outer space. Same thing down here for the ball going 5 meters per second. He's going that way, and behind it, the same direction as motion, there is a force out there. Okay, so force causes acceleration, correct? So this one should accelerate, shouldn't it? Sure. I made this up, but later he's going 5 meters per second. He was stationary. Now he's going 5. He accelerated. This guy here was going 5 meters per second before. This should speed him up, shouldn't it? I made up to 10, but it doesn't. Speed him up. Okay? So in this situation, we did see force cause the acceleration. We saw earlier, if there wasn't a force, there was no acceleration. Now, this is the formula you'll find in your MCAS formula sheet during the test, but I think you'll remember we also have this other version which is very useful because probably 8 out of 10 times you use this formula, you're asked to solve for acceleration. So this is an easier version. When you use it, there's less calculation. So here's a small problem. Brian exerts a force of 4 newtons. There's the 4 newtons, the force. Blue sheet. I want you to use a blue sheet, correct? Our mass is 2.5 kilograms. There it is. We're going to ignore friction, which means there's no force other than this one here. At what rate does it accelerate? So we want A, don't we, for acceleration. We'll choose that version there. It's easier. Copy it down. The 4 goes in for force. 2.5 goes in for mass. We divide. We get acceleration is 1.6 meters per second squared. Remember, that's our unit of measure for acceleration. Meters per second squared. Just one last thing. Sometimes you should, if you have more than one force, you should use the net force. So for instance, in that calculation, I'm sorry. So let's say you have 15 here and 5 that way. Our net force is 10 to the east, isn't it? Here they're 2 together, so it's going to be 20 newtons to the east. Here I have it down here as friction. See it down here? That's friction. So it's 15 minus 3 is 12. I'll come back to that. This one here is interesting. The two things cancel, so there really is no force, is there? There will be no acceleration here. So simply all we do here is we have multiple forces. We use the net force. We use that 12, okay? It's 12 force. It's also 12 kilograms, so we'll get an acceleration of 1 meter per second squared. The point is, if you have more than one force, get the net force first and then use that. That's it. Your video code is here. Write it down because you'll probably need it. Bye.